Hello everybody, thank you for coming. We have now a presentation about Python and Raspberry Pi. Please to do a big, huge thing for the new speaker, Ben Nutfall.
Hi everyone, thanks for coming to the talk. I'm Ben Nuttall, I'm Raspberry Pi's community manager based in Cambridge in the UK. I'm the creator of one of the libraries I'm going to be talking about today, and I'm a columnist on opensource.com. I recommend you take a look at their website. They've got some great open source materials. There's me on GitHub and Twitter, and my email if you want to reach me. I'm from the Raspberry Pi Foundation. We've sold over 11 million Raspberry Pis now in the last almost 5 years, which is really cool. A lot of people know us as the hardware company, but we're fundamentally an educational charity. I work for the charity side. We own a subsidiary which is called Raspberry Pi Trading Limited. They make all the do all the engineering, make all the hardware, and the license fee sold for each Raspberry Pi sold goes to fund our educational programs. That's how we're set up. Our mission is putting the power of digital making into the hands of people all over the world. We do this by providing low-cost, high-performance computers, doing outreach and education programs, and putting out free resources and teacher training. So we do a lot of work like that in the foundation. This is what the sort of current state of the Raspberry Pi hardware looks like. So Raspberry Pi 3 is our premium sort of main model at the moment. It's a 64-bit quad-core ARM v8 that runs at 1.2 gigahertz. It's got a gig of RAM and costs $35. So we've always had the $35 price point for our main Raspberry Pi model. A year or so ago, we actually launched a new model called Raspberry Pi Zero based on the original Raspberry Pi 1 chip in a smaller form factor that costs just $5. It runs at a gigahertz. It's a single-core ARM v6. With half a gig of RAM, but still really, really popular, really cool, really good for embedding and things. So the Raspberry Pi runs a full Linux operating system. We've created a distro based on Debian called Raspbian, based on Debian and Jessie. We've done a lot of work very recently on the sort of skin and the look and feel, the user experience of the desktop, and it now sort of looks really nice, looks like this. And we even released an x86 image fairly recently, so you can install this on a PC, on a laptop, on a Mac. You can use a live disk or a USB drive and boot into that, which is a sort of new development, a way of us to getting out the programming tools and educational content that comes with the Raspberry Pi operating system image that you could just run on a PC. One of the great things about the Raspberry Pi, that's sort of the main thing we're going to be talking about, is the big differentiator between a Raspberry Pi and a conventional PC is the GPIO pins, general purpose input-output pins. There's a set of 40 pins along the Pi that you can connect to physical devices, so you can do lights, motors, robotics, photo and video, attach all sorts of sensors, and do lots of sort of IoT sort of type of hacking. You can do some really cool stuff that you can't generally do on normal PCs. To take a look at the GPIO header, so there's a set of 40 pins, and they're each designated different purposes. So you have some pins that are 3v3, which is a constant supply of 3.3 volts. Some pins are 5 volts, a constant supply of 5 volts. You've got GPIO pins, which are variable 3v3, so you can turn them on and off, and they'll alternately give out 3.3 volts, which is how you control your components and things. And then there's other interfaces, so there's SPI, I2C, and UART, so different sort of communication protocols that you can use, high-speed data transfer, use over those pins, just over the GPIO pins. If you have a look at the website pinout.xyz, there's a full comprehensive sort of set of information and documentation about what the pins are used for on different boards and things. So two main ways of sort of accessing the things on the pins. One is sort of wiring things up to the pins or using a breadboard and connecting up your components directly that way. Or you can design PCBs which are meant to sit on top of the whole pin set and give you all the bits sort of on the board itself. So a lot of people in the ecosystem of building boards, add-ons and accessories. And we've even got a standard called HAT, which stands for hardware attached on top, which is for 40-pin headers that slot on top of the Pi and give you something specific or a more general purpose add-on board. The way you program the pins in Python, so there's a low-level library that's been around for about 4 years or so called RPi GPIO. Very low level, that looks very similar if you've used something like Arduino before. So it's all about setting up pins as outputs or inputs, setting output pins high or output pins low, and reading the value of input pins. Very low level, and my library that I sort of been working on for the last year or so, it's called GPIO 0, the 0 not being Pi 0 related, but 0 boilerplate. So the idea of this is you have component classes and you create instances of something like an LED or a button, and just give it the pin number in the construction, and you can use it, use the DSL sort of methods thereon. So you get things like, rather than turning pins high and low to flash an LED, you tell the LED to come on and tell it to go off. Or use the blink function, blink method, which sort of gives you the threading stuff for free, so it lets you sort of hack away at things much quicker. We've got a sort of multi-paradigm approach to this as well. So here I have an LED and a button. I create instances of those on particular pins. And one way of doing this, if I want the LED to come on when the button is pressed, I can just use a while loop, check the state of the button, and optionally turn the LED on or off, which works fine. That's what I would generally start with kids. Another sort of paradigm is event-driven approach. So again, you have your LED and your button, but you attach events to the action of the button being pressed and being released. So running those methods on as callbacks. And the third approach is really clever, which is sort of the implementation of this would make for a really good talk of itself, but a sort of more declarative style, which is where you connect these two devices up. So the button is constantly sending its current value into the LED. And you can do a lot of really powerful stuff with that, especially with more complex devices. The GPIO 0 library supports a range of everything from very simple devices to sort of more complex things. So you've got LED, button, buzzer, motion sensor, distance sensor, a few little add-on boards which compose of different devices. Things like light sensors. You can wire up potentiometers to an analog digital converter and read the values of those very easily. There's an Energini there, which is a remote control socket, which I'm going to be talking about later. Line sensors, sets of traffic lights, robotic add-on boards, motors, servos, and all sorts of things like that. There's a great device hierarchy on our Read the Docs page you can take a look at. There's some really interesting stuff in there. It just saves you having to work out exactly how the implementation of these devices work. You can just use the methods and stuff that the abstraction gives you. GPIO 0 supports multiple backends. It was originally just an abstraction layer on top of the library I mentioned earlier, RPi GPIO. And then we managed to bring in sort of swappable backends. So you can bring in a different pins library and use that, but get the advantage of the abstraction of GPIO 0 for free. So we support RPi GPIO, another library called RPIO. There's a great one that I'm going to cover in the next slide called Pi GPIO, which has some really nice features. If you don't have it, it sort of goes through looking at what you've got installed, and if you haven't got one of these installed, it sort of falls back to a pure Python implementation of basic pins, which is a little experimental, but kind of cool to be there. And we've also provided mock pin classes, for pin classes, so we have a test suite that runs this through sort of the logic of the API using mock, which is really cool. So back to Pi GPIO. One of the things you can do in Pi GPIO is run GPIO 0 code on your PC, on your laptop, or even on another Pi, and remotely control the GPIO pins of that Pi over the network. So you can do something like this. This is one way of doing it, where you, rather than creating an instance of an LED on a particular, just an integer passing into that as the pin number in the constructor, you can pass in a pin object and do it this way. So you can have sort of several different ones you could use, or you can set an IP address as an environment variable and just run the script as you would on the Pi itself. Also, there's the Raspberry Pi camera module. So this is an official add-on accessory that the Foundation puts out. V2 is an 8 megapixel camera. The previous one was a 5 megapixel. There's visible light and infrared versions available. So the green one is the regular visible light camera. The black one is called Pi Noir. It's got the infrared filter removed. You can do 1080p video at 30 frames per second, 720p at 60 frames per second, and VGA resolution at 90 frames per second with this camera. There's a basic sort of command line options available for capturing and doing all sorts of stuff with the camera on the command line. But there's also a Python implementation, which I'm going to show you. So the Pi camera library, this is an example of just taking a picture. So you create an instance of the connection to the camera, start the preview, sleep for a few seconds so you actually see what's coming in real time on the screen, and then capture and stop the preview. It's as simple as that. If you want to record video, it's just swap that out for start recording and stop recording. It's very easy to drop in GPIO 0 and use a push button before you capture. So rather than just an arbitrary sleep, you can wait until the button's been pressed, then capture. And there's lots of really cool stuff that the GPU does all the hard work for you, that you can supply different image effects and all sorts of different things that the library gives you and the firmware gives you. So this, for instance, you can do all these different, render all these different image effects, and they actually come through on real time as they're processed through the GPU. One of the examples in the Pi camera documentation is web streaming. So it's really simple, just a block of code that you can run a little web server that constantly streams the video. So this is actually my house. I bought a tortoise recently, and I dropped in a camera module and been monitoring it. So that's really cool. And so one thing I mentioned earlier, Energini. So this is a really safe way of controlling real live electronics that have connected to the wall socket. So real powerful, normal power socket things. So you can actually send remote commands from the Pi to turn on and off a device plugged in at the wall using this Energini module. You can use relays and things like that. Anybody who's done bits of electronics might have used relays before, but look, getting up to that sort of voltage, you really need to know what you're doing. So Energini gives you a simple way of doing that. So this is one actually set up for the tortoise as well. So using, so Energini is built into GPIO 0, and we also have some internal classes, internal devices, which sort of act like the GPIO devices and sort of connect with them really well. So we create an internal device called time of day, which is a bit like in the same way a button is active when it's pressed, the time of day is active between the times that you created. So you sort of create a time there between 8 a.m. and 8 p.m. And all I'm doing is saying the lamp should be on during that time of day. So those two, there's just two scripts running, one that I got from the documentation, one that you can see on the screen, and that had my whole sort of little hobby project set up quite easily. Another official add-on product is the Sense Hat. So we actually made this for a specific purpose, and then we decided that it'd be good that if we were able to put it on sale, because a lot of people would be able to make use of it. We made it for one of our educational programs called AstroPi. The British astronaut Tim Peake went to the space station for 6 months last year, and as part of his mission, we ran competitions for kids to write code that would be run on the space station. So they were running on this sensor board. So it's a board, it's a hat that goes on top of the Pi. It gives you an 8x8 RGB matrix, LED matrix, so you can display messages on there or change the colors and things. And it's got a bunch of sensors and a little joystick. So it just drops onto the Pi straight like that. So you can buy these as well. So simple simple way of using it like that. Just read the sensors with properties there, and you can use methods to write stuff to the screen. Just a simple example there is reading the humidity value, getting that as a percentage, and I've missed something there. Times it by 255, and then displaying the sort of intensity of the red according to the humidity. So just a simple example showing how easy it is to get something from the sensors showing on the screen. So AstroPi is the competition. It's now Tim Peake's now back on Earth, but the French astronaut Thomas Pesquet is now on the space station, and we've got a whole European-wide competition running for kids. So if you know any teachers or anyone in education, it'd be worth pointing them in direction of the AstroPi website. There's plenty of resources and stuff to get started, and you can even apply for a free kit to get started with this. One of the other things we did to sort of drive more, make it more accessible to people to get involved in that competition is to create an emulator. So you can code the Sensat in a web browser using Trinket. And it's exactly the same Python code that you write on there, and you get a visualization of it on the screen. You also get a bunch of sensors, sliders for the sensors that you can change. So it's good either if you haven't got a Raspberry Pi or a Sensat, or if you just want to test your code without needing real sensor value, real sensor data. You can test it in this emulator. As well as the one in the web browser, we've got a Python version that you can download and just run natively just on your machine. That's really cool as well. So the documentation for the projects I've been talking about, so there's GPIO.readthedocs.io, pycamera.readthedocs.io, and pythonhosted.org/sensat. So I just want to finish with sort of pointing people in a few different directions of how they can get involved in the Raspberry Pi and the community. So one thing you could do is contribute to some of these Python libraries, or help create more Python libraries for things that you can use with Raspberry Pi. There's some really interesting projects you can do at home, and it'd be great to see some contributions. And if there's any libraries you see around still using Python 2, of course, a lot of teachers have problems where they hit a brick wall when they've been trying to use Python 3 and they have to switch back to Python 2 for some particular library. So if you could help with that, that would be great. We have a magazine called the Magpie, which you can buy in shops. And you can get subscriptions for. You actually get a free Pi Zero if you subscribe to the magazine. It was originally a community magazine that they just put out free PDFs every month, just a few members of the community. They came and asked us to help them keep it going once they sort of reached that point in a sort of open source style project where they had a bit of fatigue, and we helped them out. We've actually managed to get it into the shops, so you can we have this monthly magazine, and you can buy subscriptions. So, but we still provide that as a free PDF. So do check that out. There's plenty of projects, news, and articles, and resources and things in there. We actually gave away the first batch of Pi Zeros with the magazine as well. The team that produces the Magpie also make books, so things like make games with Python, experiment with the Sensat, and things like that. We put those together as well, and you can buy the books or download them for free from the Magpie website. Raspberry Jam these are community events, sort of mixed between sort of tech user groups and sort of family-friendly tech events. They happen all over the world, really. A lot of them in the UK and the US, and a few around Europe. So have a look on the Raspberry Pi website where there's a map and a calendar of all the upcoming events. And if you want to get something started in your area, if you're a member of a hackspace or a tech user group or something, really good place to start and welcome more people into coding on Raspberry Pi. Another program that we're involved with is the Raspberry Pi Foundation's project called Code Club, which is not a Raspberry Pi specific project. It's just introducing kids to coding in schools. So it's free volunteer-led after-school coding clubs for children. We've got a big project in the UK, but there are sort of franchises of this around the world and in different countries. We provide projects in Scratch HTML and Python and provide training for volunteers. So we need help translating more materials and things, but if you want to take a look and see if you can volunteer, then take a look at codeclubworld.org. That's all. I'll stop for questions. Thank you.